Welcome to the CAD 2 Week 8 Part 2 tutorial. This tutorial is for you for after you've already created the assembly, and it's to make the assembly blueprint. Now, we're going to be mostly following Tutorial 2. Tutorial 2 is a written tutorial on creating a top-level assembly drawing, while Tutorial 1 is specifically a tutorial on how to create the section view and to get the offset hatch pattern correct. So we're going to mostly follow Tutorial 2. So, that being said, get your tutorial open, get your checklist ready if you want to be able to check off as you follow along, and start by opening your assembly file. Once we have our assembly file open, we're going to start a new drawing file. So we'll go to File, New, English, and we'll make a drawing. Okay, perfect. So, in creating a drawing, the first thing we're going to do is create our isometric view. Now, here I have my open document. I can select that to insert. It did default to isometric from this quick selection. I could also use my view selector on the right side so I can get a visual preview of what view I'm placing. But for an assembly drawing, the first page always contains an isometric view and no other views. So as soon as this loads, we'll drop our isometric view in and move on. There it goes. Okay. Isometric view, first page. Now, this is a little small for the view, so I'm actually going to update this view size. I'll right-click on Sheet 1, go to the Properties. It's currently 1 to 2. I'm going to try 2 to 3. That looks a little better. You can see my title, drawing number, and drawn by all came in filled out. That is because I filled them out in the assembly file, not the individual part files. I do still need to fill out my revision table though. So I'll put my initials and today's date. Perfect. Now some things are the same to our normal drawing process. I need to add my isometric view note. So I'll go to Blocks, Insert, Browse, navigate to your block folder, which is usually under Met Templates, SolidWorks, Blocks, and drop in my ISO view note right underneath there. Okay. Now, the first thing that is different on our drawing is to make sure we have our parts list. I'm doing this a little out of order of the tutorial. I'm trying to do it in a more natural work order. The parts list tutorial starts on page 5 and goes into 6. So we're going to insert our bill of materials. That's up here under Tables, Bill of Materials. Now you need to select what view is going to generate the bill of materials. And then what's very important is we need to browse for the correct template for our table. It's not going to be this BOM standard. This little star button next to it lets you browse for a template for your bill of materials. So we're going to go to Local Disk C, go to Met Templates, SolidWorks, and there is our bill of materials template. We'll select that and hit OK. And now we've got a table that we can insert into our view. As for location, it likes to snap to the existing lines, and we're going to snap it right on top of our title block. Okay. Now, immediately we'll notice part number came in fine, but the description of my components didn't come in, and the description and material for my bolts also did not come in. So I do need to go in and fix that. So I'm going to reopen my assembly, and I'm going to edit each of these parts. Now I'm going to click on the plate and go to the component properties of the plate. My component description is currently just set to description. This is also in the custom properties if I were to open that part longhand. So if I open the part, Wait a second for it to load. There we go. Go to the File Properties. And go to Custom. There's my description. So I'm going to make the description the same as my title. That's going to be cam plate. And select OK. I can save that. Close this component. Now if I were to right click on this part and go to the component properties, you notice my description is now cam plate. I can do the same thing for the bushing. Right click, properties, component description is just going to be bushing. Well, it's not letting me change it here. Well, I guess we do have to change it in the component. So we'll right click, open, properties, custom, bushing. Okay, save, and close. Okay, now to fix our toolbox components, we are going to right-click on the component and select Edit Toolbox Component. Now here we have part numbers. We are going to add a part number, and this will give us the part number and the description. So I'm actually going to copy this part number, which is the description of my fastener, and paste it in description, and replace part number with just the word standard. That way, we know it's a standard off-the-shelf component, and the description tells us what that off-the-shelf component is. With that, I can hit OK, and that part is set. Now I can go to my washer, do the same thing, add a part number, we'll copy that, paste it here, change the part number to standard, hit OK, and then last but not least, do the hex nut and the dowel pin. So configure component, or not configure component, edit toolbox component, add a part number, copy, paste, replace this with standard, OK, and then the dowel pin. Add, copy, paste, standard. OK, I'll select OK, save this whole thing, and with that, when I navigate back to my assembly, or navigate back to my assembly drawing, I should now see a filled out table. However, we do have one problem, and that is that the material is listed as nothing. Now, that is the way the paper tutorial does it. There is, however, another way to edit this, and for toolbox components, it's not a big deal to do it this way. If you simply double-click in one of the boxes, it's going to say, hey, this is a linked property in read-only. Do you want to break the link and override it? In this case, we're just going to say yes and type in standard here. Is this the proper way to do it? No. But it does get you the correct result, and it's much faster than doing what we just did another way. And what's important, though, is that our table looks correct and usable when we're done. Now when I click off, there's not really any visual difference. There's no way to tell unless you look at the SOLIDWORKS file. It's better to fill it out in the part file in the assembly, but it is possible to just override the table, and it's not going to be the end of the world. Okay, our first page is complete. Now we need to move on to a second page. So we'll hit the new sheet button, and it doesn't know what the sheet format is, so we need to select that. We'll hit OK, and we're going to browse for our sheet format. As with everything else, it's going to be stored under Local Disk C, Met Templates, SolidWorks, English. There's our continuation sheet. So we'll hit OK and OK. It's going to say there are duplicate blocks. Do you want to rename them? We can just hit yes or no. It doesn't really make a difference. And now we've got our sheet 2. Now on sheet 2, I'm going to go to my view palette, refresh it, and give it a second to load. And then I'm going to bring in my top view. From there, I'm going to create a section view so that I can add balloons. Okay, so we're going to drag in the top view. Perfect. Now, our regular rules still apply. I still need to turn tangent edges off. And I'm going to add a section view. So I'll go to Drawing, Section. We're going to do a horizontal section across the lower bolts with a notch to the middle. So again, when you place a notch, you place the start point of the notch, the end point of the notch, and then set the depth. Now I can hit OK, and it's important here, you'll notice Exclude Fasteners is selected. So this is going to not cut through our toolbox components, which is important. Now I can hit OK, and scroll down, and there is my view. You can see my toolbox components have not been cut through in their view, and that is really important. I'm going to roughly center this guy, and then I'll go in, and if possible, I'd like to change the hatch pattern on one of these parts. These parts use the same material, and since the crosshatch pattern matches, it makes it a little hard to tell. So I'm going to pick this component, and you can see I've got my area hatch fill over here. In here, I'm going to go in and uncheck material crosshatch and just change the angle to 90 degrees or 180 degrees. Now, unfortunately, this crosshatch does not just like a simple flip, so we'll try 30. Now that is a very distinctly different hatch pattern. I can clearly see that these parts don't line up. And that's what we want. Normally we prefer to do just like an 80 degree, or sorry, a 60 or a 90 degree hatch flip. But in this case we had to go with something a little more in between to get it to not line up. Okay. So our view is in, our section view is correct, and our crosshatch has been adjusted. The last thing we need to do is add our balloons. Now, balloons label the component based on the bill of materials. So we're going to go to the Annotation Manager and select Auto Balloon. Now, because I didn't have a view selected, it put the balloons everywhere, and I don't want that, so I'm going to hit Escape. I want the balloons specifically in this lower view. So I'll click that view and click Auto Balloon, and now I have my balloons. Now, I don't like how these came in, and we're going to make some changes. So I'm going to move this view down a little bit. These are too close. But as I move them, you see how they have this little red U, and there's a line back here? That's called a magnet line. And that magnet line actually controls where the components are. If possible, we want all of our balloons to be on one or two magnet lines, a horizontal and a vertical one. Additionally, I don't like where this arrow was pointing to, so I'm going to move the arrow to point to a more clear edge of the part. Same thing here. I can't even tell what this is pointing to. It's pointing to the hex bolt. Rather than being there, I'm going to move it up top to point to a more clear location of the hex bolt. Now, I can manually add some missing balloons. I can point to the plate here. And I can point to the washer here. Now, the problem I run into is that I don't have a magnet line up here for the washer and for the dowel pin. So I'm just going to add a magnet line by using magnet line, drawing across, and you can see it actually grabs the balloons automatically. Now I can simply use this magnet line to reposition these how I like. I've got one of every part labeled, so that is good on my balloons. Now, the last thing we want to do is add a note calling out some torque to these bolts. We want to call out a torque spec to these bolts. And according to the standard, we need to torque them to about 4 to 6 foot-pounds. Now, in order to do this, we are going to need to add a note block on our first page. So we'll go back to Sheet 1, insert a block, and browse and find the Notes block. Now, I am going to consider this note a little bit of extra credit. I'm not going to require you to do this just because I think it'll take too long for class time. But it is good to see, so I will continue to do it in this video. Now, I've put in my note block, started a note. We're going to call out this note with a triangle. And to do that triangle, we need to go into the Add Symbol option while in our note menu. From here, I need to browse for the symbols, and we're going to do flag triangle, and we want the sideways triangle. So we want the rotated 1 through 99. Select that, go back to symbols, and it should show up here. If not, I can go into here, select the symbol I want, and hit OK. That triangle is just going to represent basically bullet point 1 in our note. Now I can put my note after, which is torque. That's not how you spell torque. I added a U. That's how you spell torque. Torque to 4 to 6 foot-pounds. Okay. Now that that note is called out, I can go back to Sheet 2. I'm just going to use the Note tool, add a symbol, the 1, and I'm just going to place it next to it. Unfortunately, it doesn't seem like you can actually add it to the triangle. It won't combine it for some reason, so I'm simply going to place it there. And that will let us know that Note 1 applies to component number 3. With that, I can check my checklist. My title's filled out. That is correct. My material is set. It's See Part List, and material is set over here. Drawn by and the title block's filled out. That's correct. Revision box is filled out. Now, we actually did miss something. We need to add our revision block to Sheet 2. We'll go up to Tables, Revision, hit OK, and it should just copy our revision table from page 1. That's filled out on both pages now. That's good. Drawing contains a cover sheet. That's this. And a continuation sheet. That is correct. Bill of materials is on the cover sheet in the bottom right corner. That's correct. Isometric view is on the cover sheet. Notes are on the cover sheet if needed. That is correct. Continuation sheet has our revision table. Yes, it does now. Continuation sheet has a section view to show us the assembly. It does. Section has part number or balloons, or has part number balloons. It does. Bill of materials filled out completely. And toolbox components are labeled standard. That's everything on our checklist. We can call this drawing good, save it, and submit it as a PDF. With that, we'll call this tutorial for making the drawing complete. I know there's a few differences between this and the paper tutorial. I need to update that paper tutorial. I ran into a few mistakes on it. But for now, we'll call this good.